Math 3, Unit 8.3, Part C. Today we're getting more into how to modify your graphs. So a box and whisker plot could become modified when you indicate if outliers exist. Does anybody have any idea what an outlier might be without reading the next sentence? Very good. So an outlier is a value that doesn't follow the pattern of the other data values. Okay, so outliers could have a drastic effect on the mean and standard deviation. So if you think about this, like if everybody's like scoring, let's say on a test, like in the 80s and 90s, and then one person like just doesn't even try and like bubbles in something and gets like a 20%. When you take that 20 with the other people's, it ends up really changing the average. Like where the average normally would maybe be in the 80 and 90s, it might move it all the way down to like a 70 because of the one poor value. And so in that case, they say it makes more sense to take out the outliers because then you actually get a more accurate average and more accurate data without that piece of data in there. Okay, so in order to determine whether or not you have any outliers, you must calculate two boundaries. Okay, there is an upper and lower boundary. So we have upper and lower boundaries. These boundaries are not necessarily elements within the data set. They are values that will help you determine if outliers exist. So when you're finding the upper boundary, you're taking whatever your Q3 value is, and then you're adding 1.5 times the IQR. IQR is interquartile range. Okay? So you find the interquartile range by taking your Q3 minus Q1. Okay? So if you notice on the upper boundary, you're taking the Q3 value and you're adding 1.5 times whatever that range is. On the lower boundary, you're taking Q1 and you're subtracting 1.5 times the IQR. Okay? So basically that's the gist of it. Any data that is larger than the upper boundary or less than the lower boundary is considered an outlier. So if it's larger than the upper or less than the lower, it is an outlier. If the data is equal to either boundary, it is not an outlier. So if it's equal to it, it's fine. It's just if it's greater than or less than, okay? If an outlier exists, then the whiskers can be drawn from either Q1 or Q3 to the highest value, not beyond the boundaries. Okay, and then I'm going to be using an X to indicate the locations of any outliers. So we'll just mark it as an X on the graph, but it's not actually going to be included like in our box and whisker plot. Okay, so it says, see what you think you know. Create another box and whisker plot based upon the data below. If outliers exist, please be sure to indicate it within your graph. Okay, so when we get data, what is the first thing that we should probably do? Yeah, okay, that's good. We can start by finding the lowest and the highest, and specifically, we probably should put our data in order, okay? And so I also like to number them because this helps me with finding my median and my Q1 and Q3. So I always like to number my data. And then below that, I'm gonna go ahead and put them in order. Remember how yesterday, as we put them in order, we just kind of cross out our numbers to make sure we don't miss anything. So my smallest value is 1, and then the next one is 10. Good. And then, good. Good. There are 3 15s next. Good. And there's actually 2 16s. Good. 1 17. 18. 19. Yes.
Are you just putting it in order, like
ascending order?
Oh, okay.
Always want them in smallest to biggest when we're dealing with the data. Yeah. So we get 20.
21. 25.
Good. 21, 25, and then 42. So, all right, so we have our data. We have to find the same 5 values that we found yesterday. Okay, so some of those values are pretty easy because they're just right there. So we have our, and I'm just going to highlight these right now. This value is my, I'm going to put L for low. This value right here, and actually I probably should just circle the number, but that's okay. This one is my high value. Since there are 15 pieces of data, what would be my median on this one?
Number 8.
Very good. So number 8, which means it's a 16. Very good. So this right here is my median. And then we need to find our Q1 and Q3. Very good. So the value here at 4, which is 15, is my Q1. And then at 12 here, this is my Q3. Is everybody okay with all that? Any questions about those 5 pieces of data? Okay. So now if you go back to the instructions, we first need to find our IQR. So our inner quartile range is, if you look back there, what 2 values do you subtract?
Q3 and Q1.
Good. And so my Q3 value is 20 minus
15.
Good. So 20 minus 15 gives me a value of 5. Okay. So my IQR is 5. Now again, looking back, let's start with our upper boundary. So I'm going to label that as UP. Or sorry.
UB.
Thank you. You have to know your letters. Okay. And so I'm just going to move this for a second here. So for finding our upper boundary, we're taking our Q3 value, and then we're adding it to 1.5 times the IQR. Okay? So what values am I going to write? 20 plus, good, 1.5 times 5. And that's based on the equation that we have right here for my upper boundary. So if you need to highlight this, you can go back and see where the upper boundary equation is, and then we have a lower boundary equation. So if you take 1.5 times 5, very good, at 7.5. So I have 20 plus 7.5, which makes,
27.
very good, 27.5. Then we have our lower boundary, which I'll abbreviate with an LB. And on that one, what I have to take which values? Q1, which is 15, minus 1.5 times 5, and that is 15 minus 7.5, which makes 7.5. Very nicely done. So if we look at our data for the upper boundary, is there anything that is bigger than 27.5? Very good. So we have, so I'm just going to write over here, outliers. So an outlier is 42. So that's the only one on the upper side. And are there any lower? Number 1. So now we're going to make our box and whisker plot, but those values aren't going to be part of the box and whisker. So we're not going to like connect any lines to them, but we're just going to make X's on the graph so we see that they're actually there. So we're going to go to 1. I'm just going to do, okay, one thing that we have to make sure that we do when we're making a graph is you have to label your x-axis, right? And so if we have a value at 1 all the way up to 42, I'm going to maybe start with this being 0 and then going up by 5s, and we'll see what happens here. 10, 15. So this works out perfect. And then I'm just going to do it in the middle of the graph just because I want to. So 1 is an outlier, so I'm going to put an X right here to represent an outlier. And then the next point then, so that means that my minimum or low value now will be at 10. So we're going to need to make a point at 10 because we're going to make our box and whisker plot right now. The next point I'm going to have is at what?
Green.
16. So just a little bit past the 15. And then we still have, in this, so this was our median is at 16. So if you wanted to label them, you can. This was now my, no, this is my Q1, right? Oh, I forgot to put one at Q1. Okay, so Q1, sorry. And then Q3 we still have at 20. And then my high value will now be 25. And then we're going to put an X at 42. And so now we're going to make our box and whisker plot. And so we're going to draw a line from our low to Q1 and our high to Q3. And then we're going to make a box around these values, and then our median is there through that point. Does this look more like proportional? Yes. Okay, so ask me any questions, anything that you're like, I don't get this, so I can try to re-explain. Yes.
So you just use like
So basically, if you have an outlier, and in this case we did, our low value for our box and whiskers is just going to move to the next point. Is that what you're asking?
Oh no, I meant like to move. Oh, you can put it wherever you want.
Oh yeah, you can put it wherever you want. I just like more space. And the only thing you have to make sure you do is label your x-axis.
Yeah.
Okay? But yeah, your graph, you can, and you could have labeled it by like 10s or 2s or whatever you want to do, as long as it's labeled. Yes?
Okay, I think she literally just asked this question, but is there a specific reason you wouldn't 3 up?
No.
Okay. Is that the question she just asked?
Yes. So yeah, you can put it wherever you want to. I just like it to be above.
Okay.
That's
I like
it.
in the middle.
Yeah. And I didn't even quite make it quite in the middle. I don't know.
See, me gusta.
You can put it wherever you want, as long as you have the x-axis labeled. That's the only thing that matters. Okay, anything else? All right, we're going to move on now to percentiles. So I'm sure you guys hear a lot about percentiles, like with SATs and ACTs and different things, like what percentile you want to be in, maybe what percentile you are in, maybe what you don't want to be in, I don't know. But this is how percentiles work and how they figure out these numbers. So it's a way to measure the location of data in relation to other data, okay? The value of the percentile range is between 0 and 100, which would make sense because really there isn't anything more than 100%, right? Even though there's extra credit and stuff, it's really 0 to 100. Okay, as an example, the 95th percentile means that 95% of the data values are less than or equal to that value. X is location of wherever that data point is. Okay, so how to find a percentile? You must first list your data in ascending order, which we've been doing that the whole time, okay? All data values must be included in the ascending list. In addition, you must find out how many items you have in your list of data, which again, we're doing most of the time, right? We're numbering our data, we're making a list from lowest to highest. Okay, so how far to count, which means the value you get from the right indicates how far to count in your ascending list. There are 2 possible results. You're gonna look before. Hold on just a second. Basically, the main idea here, this is what your answer is. N is the number of data values. So depending on, so in this class, we have 14 people right now, okay? So if we are taking to see what percentile you are in this class, we would take our number 14 people, and then you would multiply it by the percentile. So if you wanted to see, well, how many people are in the 95th percentile, then you take that and multiply it by 0.95. Okay, we're going to practice this. It'll make more sense. Okay, the one thing, though, that you need to remember is when you're doing this, if you get a whole number, when you finish, then you add 0.5 because you're taking the average between two values. Okay? If you get a decimal, you round up. Regardless of what the decimal value is, you will round up. So let's say you got like 5.1. You would round up to 6. Okay? All right, that's important. We are going to find the 37th and 60th percentile for the data below. So if you look here, the first thing you'd want to do is count the data. They have already done all this work for us, but I would like us to kind of still go through it and number some of this. So we're going to start by numbering our data. So if you notice here, there are 20 pieces of data. They want to find the 37th percentile, and so a percent, 37% as a decimal is 0.37. So you multiply 20 times 0.37, and you get 7.4. Because this is a decimal, we would round it up to 8. So it says the 37th percentile is the value 32. Do you see here how this is 8? So if you're in the 32nd percentile, you would have a score of 32. Because you would go to the 8th number in your data set, which is why it's important to number your data set. So this number is telling you where you go to in your data set to find that percentile. So if you had a score of 32, you would be in the 37th percentile. Okay? So 60th percentile. We already know there's 20 pieces of data. So we go 20. 60th percentile is 0.6. Okay? 20 times 0.6 is 12. Since this is a whole number, we add 0.5 to it. Okay? So 12.5. If you go to 12.5, it's right here. Okay, it's between two numbers, and so that's where we take the average of those two numbers. So we add them together, divide by 2, and we get 67. So what that means is the 60th percentile is between 56 and 78, which is about 67.
So you take the average.
So anytime you have a whole number, you're going to make the number 12.5, and you're going to average the two numbers that are there for the actual value. Okay? So let's try this on our own now and see if it will kind of make a little bit more sense. So what's the first thing we should do with this data set?
Number it.
Number it. I like to make a chart, and there's actually 20 of them, but I kind of did it like how we've been doing on all the other ones. And so I made 2 rows. And I'm going to go through and make the 20 marks and count to 20. So I'm going to give you guys a minute to kind of organize this and see what you can do with finding the 45th percentile. So make sure as you put your data values on there that you're crossing them off, but you should end up with 20 values.
Making sure I actually observe 0, 30, 6. Oh, you have to put it in the ascending order.
Yes, you have to put it in ascending order. And then remember when you're multiplying like 20 times whatever the percentile is, then that tells you the number you go to, which gives you the value of that percentile. Okay, so you should have listed all of your data. I'm gonna go ahead and put my numbers in here really quick. 2, 5, 11. Do you guys want me to be quiet? Are you still working? Okay, so that's how your data should have been listed. So in order to find the 45th percentile, what do I need to do?
You need to find out how many numbers you have, which is 20.
Good. So we're going to go 20 times what?
0.45.
0.45. Okay, so when you multiply that, what did you guys get? 9. So whenever you have a whole number, we move that to 9.5. What does that mean in terms of my data? Right, so I'm going to 9 and 10 in my data set, but those actual values are 34 and 45. So that means that the 45th percentile is between 34 and 45. Because it's not like we have a number for every single number in here. Does that make sense? So the 45th percentile is in between 34 and 45. So you would need to take the average of those, 34 plus 45. We divide that by 2. So that's 79 divided by 2, which is 39.5. So the score of a 39.5 is the 45th percentile. Okay? So if you're going to the 45th percentile, if you want to be at least in the 45th percentile, then you have to have a score of a 39.5 or above. Let's say your goal is 45th percentile or greater.
Why did you make the 9 and 9.5?
So that's one of the rules with percentiles. If you end up with a decimal, you round it to the nearest whole number. If you have a whole number, you bring it to a half.
Okay.
It's one of those things you just have to remember.
Okay.
Okay, so 90th percentile. Okay, 90th.
Wait, but then wouldn't the last one be wrong then?
Wouldn't the last one be wrong?
This one back here. This is 64. This is 64. 7.4, so round up to 8.
Right. So you round it. Like, so that's what we're talking about. If it's 0.2, you would round it up to 8. Any decimal, you round to the next whole number.
Oh, the next whole number. Okay, so you don't round down. Okay.
Right. Only rounding up. Okay, so 90th percentile. What will I do?
20 times.
Which is? Good. And since it's a whole number, we're going to round that to?
18.5.
Very good. And so since it's 18.5, that means I'm going to go to which two numbers? 18 and 19. And so we take those, 90 plus 91 divided by 2. And that's 181 divided by 2. And I don't know why I did all that work, but it's there. And so you get 90.5. So the 90th percentile would mean you would need to score 90.5 or better in terms of being at the 90th or better percentile. Okay. And we are not going to worry about question number 1 right now. Do we have any questions on what we did right there? No?